We're going to look at the characteristics of these two graphs. Again, the question's just saying to find the non-permissible values, then determine oblique or horizontal asymptotes. That's sort of the order that we've been doing so far. First, we're always looking for our non-permissible values. So in these ones, it's not bad to even label that. I want to find my non-permissible values. I always factor to begin with. This one, the denominator factors because it's a difference of squares. So our non-permissible values, x can't equal -2, and x can't equal 2. Do any of those non-permissible values cancel out now that we've factored? No. So we're going to have vertical asymptotes at x equals -2 and x equals 2. So the first thing you're going to look at is your non-permissible values. Your non-permissible values are either going to be holes in your graph or asymptotes in your graph. In this case, nothing simplified, so they are both vertical asymptotes. The second thing you're going to look at is horizontal asymptotes or oblique asymptotes. And you can tell that by looking at the highest degree in the entire fraction. In this case, the highest degree in your entire fraction is an x squared. We have 1x squared on the bottom. We have no x squareds on the top. Whenever the degree is larger on the bottom, you have a horizontal asymptote at y equals 0. At this point, we're going to start to graph based on what we already know. We know that we have asymptotes at x equals -2 and x equals 2. And we have a horizontal asymptote at y equals 0. Next thing you're going to look at is where are all of our x-intercepts on our graph? Do we have any? So if you look at the fact that we factored this one, the only time that you're going to get an x-intercept, plug in 0 for y, and the only time a fraction is equal to 0 is if your numerator is equal to 0. So we're going to have an x-intercept at 4. Again, that feels funny because it's on your y equals 0 asymptote. But we're going to find out what that does and how it's going to look. How did I figure out 4? I looked at my factored version because you find an x-intercept by plugging in 0 for y. So instead of having y here, I'd have 0. And the only place a fraction is equal to 0 is if your numerator is 0. Next, we can also look at our y-intercept. Y-intercept is even easier to figure out. You plug in 0 for x. I would use my original equation. Can you see you'd have -4 over -4 if you plugged in 0 for x? So we're going to have 0, 1. So we label our y-intercept, and we found our only x-intercept. Okay? I know that this section has to go up towards my asymptotes. It can't go down towards my asymptotes because if it went down, I would get more x-intercepts, and I've already found my only x-intercept. Okay? If I want to find out what's happening in this section where x is less than -2, I'm going to plug in a value like -3. What happens when you plug in -3? Can you see that on the top of the fraction you're going to get -7? Negative 3 squared is 9. 9 minus 4 is 5. You would get negative 7 over 5. What does that look like on our graph? That would be a point right there. Was it negative 7 over 5 or 9 over 5? 7 over 5. Perfect. And because I know that I cannot have any more x-intercepts, this section has to look like this. Our final section, to figure out what it's going to look like, you could plug in 3. Right? That's one higher than this. If I plug in 3, can you see that you would get negative 1 on top, 5 on the bottom. So again, we are using our table of values a fair bit here. I have 3 comma negative 1 over 5. Well, that's going to tell me that this part's going to have to go down towards my asymptote. What's happening after our x-intercept of 4? For example, if you plug in 5, okay? If you plug in 5, can you say that you'll get 1 on the top, and 25 minus 4 would be 21? And so that's a positive value. 5, 1 over 21. And so the graph goes up for a bit, but then it eventually will have to flatten out and approach your asymptote again. It actually doesn't go up very much at all. Probably reaches a maximum shortly after.
So you get marks up if you did it tonight?
Well, if you kept on going up forever. Again, in my experience, and what we're going to find out by doing enough of these graphs, there are certain graphs that tend to not show up on the final exam. This being one of them. Okay? You don't like that one? Okay, let's look at B. If we factor this one, we have x plus 2, x minus 2, over x plus 3, x minus 3. Part 1, always looking at your non-permissible values first. Our non-permissible values, x can't equal negative 3, x can't equal 3. Are those going to be holes or vertical asymptotes? Vertical asymptotes, since nothing's simplified, so we'll have a vertical asymptote at x equals negative 3 and 1 at x equals 3. Part 2. Looking at your horizontal asymptotes or oblique asymptotes. Again, we look at the highest power in this is an x squared. We have 1x squared on the top and 1x squared on the bottom. That simplifies to y equals 1. That will be a horizontal asymptote. Again, no oblique asymptotes in this one. So when going to graph this one, we have 1, 2, 3, 1, 2, 3. Our 2 vertical asymptotes, and at 1, our horizontal asymptote. If you want to find your y-intercept and you plug in 0 for x, can you see that you'll get 4/9? 0, 4/9 is your y-intercept. If you look at your factored form of your equation and you make y equals 0, the only place a fraction is equal to 0 is if your numerator is equal to 0. Our numerator is going to be equal to 0 at negative 2 and 2. So our middle section is already defined. In order to figure out what's going to happen when x is bigger than 3, plug in 4. What happens when I plug in 4 Going to get 16 minus 4, which is 12. 16 minus 9, which is 7. Wow. 12 over 7.
That's simplified.
And 12 over 7 is slightly bigger than 1. And we know this looks like that. And you might realize that because they're squaring, negative 4 will also be 12 over 7. Because negative 4 squared is the same as 4 squared. And so our final graph looks like this. Questions 9 and 10 for practice.